Okay fellas, I'm going to give you a demo now, so I want you to watch the screen. Don't be doing this on your iPad. Your teacher can play this again so you can go through the steps with me later on. Basically we're going to go into our angles chapter, which is what we're working in still. Going to go to exercise 504 and when I click on that page, you can see there's the blue box that we've been working on so far with the complementary angles, supplementary angles, the angles around a point and the vertically opposite angles, and you've done the theory on that now, so we're ready to do some practice. Down the bottom of this page you'll see there's a Geogebra activity. That's the app that got you to download earlier this lesson, and when we click on one of those four grey pointing fingers on the left there, it'll take us into the app. So I'm just going to click on the very first one here, and I know that it's going to take me through Safari. Click on the Open in Geogebra, and then you'll see what we've got is the vertically opposites activity. Now what we know from vertically opposite angles is that they are the same. So you can see here I've got two angles marked in blue with a little A and a little thing that looks like a W, and they're both 134 degrees. Then I've got the red angles, which is the little thing that looks like a B and one that looks like an E, and they're both 46 degrees. And they're the ones that are opposite each other. The blue ones are opposite each other, and the red ones are opposite each other, and they are the same. Now, what you can do in this little app is you can move the angles around. So I'm going to grab point C there, and I can start to adjust it. And you'll see that as I move it around, the red angles always equal one another, and the blue angles always equal one another. So whenever the opposite angles are moved around, they always stay the same. And that's what a vertically opposite angle does. Okay, no matter how big or small, its opposite angle, its twin brother, always looks the same. They're like identical twins. Okay, so I'm going to make the blue one as big as possible. The red one goes down. I can spin it around. Okay, that's our vertically opposite angles. Back in the text, and we're going to move on to the next activity, which down the bottom there is angles at a point. So I'll click on that. Takes me through Safari and into the app. You can see here we've got something that looks a bit different. This time four different angles, different colors. But what I want you to notice, fellas, is that down the bottom there, they equal 360 degrees. So, if I change any of those angles, I'll change the yellow one, see it's getting smaller, the green one's getting bigger, they always add up to 360 degrees. It doesn't matter what you do, you can't break it, it's always going to equal that magic number 360 degrees. If I had more angles in here or less angles, the theory would still hold. Here I can see making them really small. That just means the green one gets bigger to compensate. Okay, I can make a special type of angles at a point here, which is vertically opposite angles, and you can see that the blue and yellow ones, I've almost got them the same. Green and red I've almost got the same. They are vertically opposite, so they're equal to each other, and they're also angles at a point. So they equal 360 degrees, and I'm just a couple of degrees off there, so don't worry. Okay, back into the text, we're going to look at adjacent angles now, through Safari, into the app. Okay, and what we have are two adjacent angles, X and Y, and I'm going to actually just adjust angle BAD to make it equal to 90 degrees. You can see there, that's the black number on the bottom left. And what you have now is X and Y are adjacent complementary angles because they add to 90 degrees. I'm going to tick show both of those angles, and you can see as I move that ray AE, those two angles, angle DAE and angle BAE, always equal 90. No matter how big or small one of them is, the other one will be the complement. In a second you'll be able to play around with this and you can make them as big or as small as you like. But there's a piece of theory here that tells us, it's kind of useful actually, so if I didn't know one of these angles, the fact that they're adjacent complementary angles means that I can always figure out the unknown angle. I'm just going to set them so that the red one is 60 and the green one is 30. And then I'm going to take off the value for 60 so that we just have x. So x is now an unknown. What is it? Well, I ask myself, what do I have to add up onto 30 to equal 90? And of course, the answer is 60 because we just had that up then. But this would hold for any angle at all. So there you go, you can see it's 60. I'll turn it back off. And then I'm going to adjust the line again. So the green one is now 50. What would the red one be? Well, what do I add on to 50 to get 90? The answer is, someone shout it out hopefully. Hopefully someone got it right. I'll turn it back on and we can see that the red one was 40. Congratulations if you got it right. So 40 plus 50 equals 90. As long as you know one of those angles and you know that it's a complementary one that they add to 90, you can always figure out what the other angle is. That's pretty nifty, and that'll be in your exercises. And I'm going to make this into a supplementary angle. So supplementary angles add up to 180 degrees, a straight line. You can see there angle BAD is 180 degrees. I can move that same line again, AE, around about, and those two angles, x and y, always equal 180 degrees because they're supplementary adjacent angles. I've turned the green one on, and if I adjust that to 40, now you should be able to figure out what is x. What's the value of x? Well, I'm asking myself, what do I add onto 40 to get 180? The answer is 140. Well done if you got it. And that will be the same for any of these angles. Okay, fellas, I'm going to stop talking now and I'm going to let you play around with that app. I want you to look at each of the three different exercises that we've looked at and play around with all those angles. Be thinking, why are these angles the same? Why are they different? What do they add up to? I want you to turn the tick boxes off and try and predict what the angle will be and test yourself, test the person next to you. You'll have plenty of time for this. After a little while, your teacher's going to stop you, put up the exercises that you need to do. They are all questions that we've done today, the theory. So if you get stuck, you go back to that blue box in your text and have another read of it. Or you can watch this video again. I'm going to leave it up on Schoology so you can watch it from home with your parents if you get a bit stuck. Okay? Any work not done will be for homework. And I will see you later on in this week when I'm back. Good luck, fellas.